Okay, we will continue on page 39, picking up at example 8. Alright, so we have x to the 5/3 divided by x to the negative 2/3. Again, we're dividing with like bases, so we will need to subtract the exponents. Okay? Like bases and a division. So that means we will take x to the 5/3 and we will subtract, putting this in parentheses, the negative 2/3. 5/3 from here, the negative 2/3 from here. So this becomes, when you're subtracting a negative, it becomes a positive 2/3. And finally we can simplify this. X to the 5/3 plus 2/3 is 7/3. In number 9, we have m to the negative 6/7 divided by m to the negative 5/7. Again, we're just subtracting. We're dividing with like bases, so we'll subtract the exponents. In this case, we do have a negative 6/7, so it will stay the same. We will subtract because of the rule, and the second exponent that we are subtracting is again negative. And we continue to simplify. So this stays m to the negative 6/7. And here, when you're subtracting exponents, when you're subtracting a negative, you have to add the exponents. Now simplifying, we have negative 6/7 plus 5/7 is negative 1/7. And the last step we have to do is simplify our exponent and make sure that it's not negative. So let's think about this as over 1, and we can bring it down, leaving behind a placeholder of 1 up top, m to the 1/7, which we could think about as 1 over the 7th root of m. These are both equivalent answers. Okay, in number 10, we do some distributing. We have x to the 1/2 times x to the 1/2 minus 3x to the negative 1/2. Okay. So this is going to take some good bookkeeping skills and being careful about what we're doing. So what we might do is always look and see if you can simplify before you just start distributing. Also identify what the exponent is attached to. So this 1/2 is attached to x. I think that's clear. However, here we need to make sure that we're okay with this. Okay? This negative 1/2 is only attached to the x. So let's rewrite this as x to the 1/2 times x to the 1/2 minus 3, remember this is over 1, and we'll bring it down, over x to the positive 1/2. Notice this 3 stays where it's at because the exponent is not attached to it. All right. Now let's begin the distribution. So I'm going to take the 1/2 of x, x to the 1/2, and multiply it by the first term, x to the 1/2. Then I subtract from here, and I'm going to distribute this x to the 1/2 times now 3 over x to the 1/2. I do this so I won't get myself confused. Right? This could begin to look very complicated, but we really only have 2 terms here. Here's our first term, here's our second term. And the nice thing about terms is that they are stuck in between these plus or minus signs, which provide a barrier for us, which means we can just work term by term to simplify. And if we just work with this term, it's a lot less intimidating. We are multiplying with like bases, so we'll add the exponents. So this becomes x to the 1/2 plus 1/2, this term. Okay. Now minus from the formula, and you can think about this as over 1, and we see then clearly that these will cancel, and we're left with 3. Now simplifying this last term, x to the 1/2 plus 1/2 is x to the first minus 3, which we generally just write as x minus 3. Let's try a different one. Okay. In number 11, we are going to square that quantity. But now the difference is that in that quantity there's an addition. It's not straight multiplication. So we will have to use a different rule. Okay. Now notice these are opposites of one another. They are not like terms, so they cannot be combined. So we're going to have to FOIL. Let's write out what this means. This means x to the negative 1/2 plus x to the positive 1/2 times x to the negative 1/2 times x to the positive 1/2. And we will need to FOIL. Okay? So we'll take our first and our first. I'm just going to write these right next to each other so we can see this happen. X to the negative 1/2 times x to the negative 1/2. This is our first terms. Now, plus, we need the outer terms. So x to the negative 1/2 times x to the positive 1/2. Okay. When you're doing this, don't get confused with the exponents. Just hold very clear to what you're doing. And this is the outer, plus. Here is our inners. X to the 1/2 times x to the negative 1/2. These are the inners. Plus, and now our last. That's x to the 1/2 times x to the 1/2. And these are the last. So again, it might look more confusing, but we have 4 terms. Here's the barriers of the plus signs. And we are free to simplify those one at a time. And this becomes a much more simple exercise to do it that way. Right. So in green, we are multiplying with like bases, so we need to add the exponents. So this is x to the negative 1/2 plus a negative 1/2. In the orange, again, we're multiplying with like bases. So this is x to the negative 1/2 plus 1/2. In the orange, that was the orange. In the blue, we have x to the 1/2 plus a negative 1/2. Plus, here, x to the 1/2 plus 1/2. Alright, so we're slowly bringing it down and simplifying it, and now we'll continue. This becomes x to the, negative 1/2, just to remind ourselves, when you're adding a negative, we're subtracting. Plus x to the, and now here it's not so confusing, a negative 1/2 plus 1/2 is 0, plus x, again here, to the 1/2, adding a negative is subtracting, plus x, and 1/2 plus 1/2 is 1. We're almost there. So now we have x to, simplifying this, negative 1/2 minus 1/2 is negative 1, plus x to the 0, plus x to the 0, plus simply x. And now we want to write this without any negative exponents. So this is the same thing as 1 over x to the positive first power plus anything to the 0 power is 1. Here we also have x to the 0 power, which is 1, plus just x, which we could write as 1 over x, combine these like terms, plus x. So this is why good note-keeping skills and being neat about what we're doing will help us. This looks like a very confusing problem, but we have to remember taking it one at a time. This simply means to square, so I need to write that out. Once I have that written out, I know I need to FOIL. Then, taking it term by term, I simplify each, remembering the rules of rational numbers and adding and subtracting fractions, until in the end, we come to this. Let's try a different one with number 12. Okay. With number 12, we have the quantity 16x to the 8th to the negative 3/4 power. Okay. In this case, our base is the entire 16x to the 8th. I still prefer to work with positive exponents, so that's what I will do first, because I can move this down. Remember, there will be a placeholder up top, and now the base, 16x to the 8th, comes to the 3/4 power. And now we have a couple of options. Okay. here we have a product that's being raised to a power. So that's the same thing as taking the first factor to the 3/4 power and multiplying it by the second factor raised to the 3/4 power. So it might be easier to see it like this. Which is equal to 1 over from here, this is the same thing as the 4th root of 16, and then I'm going to cube that, rewriting in a fractional, rational form. And here, remember we can think about this as 8 over 1, and we can do some canceling. 4 goes into itself once, and into 8 2 times, and 2 times 3 is 6. Which is equal to 1 over. Okay. Now here we can ask ourselves what the 4th root of 16 is. If I take the prime factor of factorization of 16, it's 2 times 2 is 4, times 2 is 8, times 2 is 16. There is a group of 4 2's in 16, so the 4th root of 16 must be 2. And that is cubed times x to the 6th, which is equal to 1 over, and finally 2 cubed is 8, and the x to the 6th comes along. Okay, let's try another one. 13. 25 over x to the negative 6th, raise that to the negative 1/2. I want to simplify first if at all possible. And inside of here, I have a negative exponent to get rid of. I can get rid of this negative exponent by moving it up top. So this becomes 25x to the positive 6th. And notice that does not change this negative exponent out top. Now that I've simplified inside of here, I would like to get rid of this negative exponent. I can do that using the rule that says we will take the reciprocal and now make this positive. So I had 2 negatives to take care of. This negative became positive by moving up top. This negative became positive by taking the reciprocal. Now let's apply, this is a quotient. So if a quotient is raised to a power, that's the same thing as taking the entire numerator and raising it to the first power, or to the power, and the entire denominator and raising that to the 1/2 power. And now we simplify. So the root here that I'm taking is going to be a square root. So this is the square root of 1 divided by the square root of 25x to the 6th. the square root of 1 is 1. It's one of the reasons we like it, that number. In here we will have to think. This is the same thing as the square root of 25 times the square root of x to the 6th. We know the square root of 25 is 5 because 25 is 5 times 5. But what's the square root of x to the 6th? We can think about this in two ways. Remember, this is x to the 6th raised to the 1/2 power. If we went power to power with this, we would multiply, and we would get x to the 6 over 2, which is x cubed. There's another way to think about that as well, though. The square root of x to the 6th. Okay. X to the 6th is x times x times x times x times x. 1, 2, 3, 4, 5. One more. 6 times. Okay. We said the square root of 25 is 5 because 25 is 5 times 5. There was a group of 5s. So, if I look here, then I see a single group of x. So they could come out as a single x. Here's another group of 2 x's. So they could come out as a single x. And lastly, there's a second group of 2. They could also come out as a single x. And so in this way we can see that the square root of x to the 6th is x cubed. This will take some practice, but give it some thought. Okay, let's move on to our last two, where things get a bit complicated because we're putting it all together. So 14. 4x to the negative 3 y to the 6th over x cubed y squared, and then we're going to raise that entire thing to the 3/2 power. It is very important that we simplify before we move forward with this. Okay. So we could think about this as 4 times x to the negative 3 over x cubed times y to the 6th over y squared, all still raised to the 3/2 power. Now, let's simplify. There's nothing to do with the 4. There is no other thing to cancel, so it's 4 times, now here we're dividing with like bases, so we'll subtract the exponents. Negative 3 minus 3. And here, again, we're dividing with like bases, so let's subtract these exponents. So this becomes 4 times x to the negative 6, y to the positive 4, all raised to the 3/2 power. Again, getting rid of the negative exponents. This is the same as 4y to the 4th over now x to the positive 6 raised to the 3/2 power. Now we've simplified inside as much as we possibly can. So let's begin with the power. Okay. So our rule says with a quotient, you take the entire numerator and raise it to that power. And we can divide the entire denominator raised to the power, which is x to the 6th.